Complete the following generic rectangles. Find the length, width, and area of each smaller rectangle. So I know x times x will make x squared. I have -5 here, so I need 1 times -5 to make -5. X times -5 is -5x. 1 times x is x. 2x times x is 2x squared. 2x times 1 is 2x. 1 times -4 is -4. And -4 times x is -4x. Here I know x times x will give me x squared. X times -1 will get -x. X times -3 is -3x. And -1 times -3 is +3. So that works. Zachary has $718 in his bank account and automatically withdraws $14 every month. Christian has $212 in his bank account and deposits $32 each month from his newspaper. Assuming they make no other deposits or withdrawals, when will Zachary and Christian have the same amount of money? So I'm going to make an equation. I'm going to let M equal number of months and D equal number of dollars. So for Zachary, his dollars equal, let's see, 718, that's what he starts with, minus $14 every month. Christian, his dollars equal 212, that's what he starts with. And he adds, so he adds $32 each month. So I want to know, when are their dollars the same? So I'm going to substitute this in for dollars here. So we get 718 minus 14m has to equal 212 plus 32m. I'll add 14m to both sides. We get 718 equals 212 plus 46m. Subtract 212 and we get 506 equals 46m. Now to do this, I'll do this on the calculator. Divide by 46 on both sides. And 506 divided by 46 is 11. So they'll have the same amount of money at 11 months. Solve each equation for the indicated variable. So we want to solve this one for x. So I'm going to subtract 3y on both sides first. And we get 2x equals 6 minus 3y. Then divide by 2 on both sides. And we get x equals 6 divided by 2 is 3 minus 3/2 y. We want to solve this one for f. So first I'm going to add 3 to both sides. So we get fm equals q plus 3, divide by m, and we get f equals q plus 3 over m. We want to solve this one for r. So first I'll subtract a from both sides. So we get r over s equals 2b minus a. Then I'm going to multiply both sides times s to cancel there. So we get r equals s. We could distribute it out, but instead I'm just going to say s times 2b minus a. Find the slope and the y-intercept for each line below. So we need to put it into y equals mx plus b form. So we need to solve for y. So first I'll subtract 2x. So we get 7y equals negative 2x plus 14. Divide by 7. And we get y equals negative 2/7 x. 14 divided by 7 is 2. So the slope is negative 2/7, and the y-intercept is 0, 2. In this equation, it's already kind of in y equals mx plus b form. I'm going to change it to y equals x over 3 is the same thing as 1/3, negative 1/3 x plus 6. So the slope is negative 1/3, and the y-intercept is 0, 6. Here I'm just going to divide out. So y equals 10 divided by 2 is 5x. 2 divided by 2 is 1. So the slope is 5, and the y-intercept is 0, negative 1. In this one, this would be the same thing as saying plus 0. So the slope is 3, and the y-intercept is 0, 0. Find the domain and range of each graph below. Assume the parabolas have arrows on the ends. So remember, the domain is the possible x values. So the domain of this graph is going to keep going out and out and out forever. So any x value could be on this graph. So the domain is all real numbers. Or you could write it as negative infinity to positive infinity. The range is the highest y value is 3, and then they just go down from there. So the range is either negative infinity to 3, or you could just say y is less than or equal to 3. On this one, the parabola is flipped on its side. It's a sleeping parabola. So the domain, all x values aren't possible here. The highest x value is positive 3. So we could say x goes from negative infinity to 3, or just x is less than or equal to 3. And then the range, because this parabola will go up and down forever, the range is going to be all real numbers. Or we can write it as negative infinity to positive infinity. For this circle, it looks like x goes from negative 2 to positive 2. So the domain is negative 2 is less than or equal to x, less than or equal to positive 2. And the range goes from, let's see, 0 to 4. So 0 is less than or equal to y, less than or equal to 4.